SUVs, they're big, bold, and built to do it all. But behind that commanding stance and tough look lies something most people never think about: the deep science and precision engineering that make these vehicles both powerful and safe. Today, we're breaking down exactly what makes modern SUVs so strong, so stable, and so smart on the road. Let's start with the basics: the shape. That tall, elevated ride height that gives you a better view of the road also raises the center of gravity. In simple terms, it makes the vehicle more likely to lean or tip in extreme situations. Engineers know this, and they fight it with clever design. Heavy components like the engine, battery, and fuel tank are mounted low in the chassis. The track, that's the distance between the left and right wheels, is widened. And lighter materials are used in the upper body to keep the weight down high up. The result? A big, tall SUV that behaves like a smaller, more stable car when cornering or braking suddenly. Then comes the skeleton, the chassis. There are two main types: unibody and body-on-frame. Unibody SUVs, like most crossovers today, have the body and frame fused into one strong shell. They're lighter, handle better, and absorb crash energy more efficiently. Body-on-frame SUVs, on the other hand, like traditional off-roaders and towing machines, have a separate frame underneath the body. That gives them incredible strength and durability, especially on rugged terrain. It's the reason why vehicles like the Toyota 4Runner or Ford Bronco can take such a beating off-road. But the trade-off? More weight and a stiffer ride. So engineers choose the right structure based on what the SUV is designed to do: comfort and family hauling, or pure strength and endurance. Now, what makes an SUV truly capable is its drivetrain, how it delivers power to the ground. Most SUVs today use all-wheel drive or four-wheel drive systems. All-wheel drive is automatic. It constantly adjusts how much power goes to the front or rear wheels depending on traction. Four-wheel drive is usually driver-controlled and includes a low-range mode for serious off-road climbing or towing. Modern SUVs go even further with something called torque vectoring. This technology sends different amounts of power to each wheel to help the vehicle turn more naturally. Imagine taking a sharp corner and feeling the SUV stay planted instead of rolling outward. That's torque vectoring at work. And in electric SUVs, this becomes even more precise, since each wheel can be powered and controlled independently by its own motor. But even with power, control is everything. And that's where suspension engineering shines. Modern SUVs use adaptive suspensions that can literally think on the go. Air suspension systems can raise the SUV for rough terrain and lower it on highways for better stability and fuel efficiency. Active anti-roll bars powered by 48-volt motors counteract body lean, keeping the vehicle level through fast turns. These systems read road conditions in milliseconds, adjusting damping, stiffness, and height constantly to keep your ride smooth, stable, and safe. And when it's time to stop, the science doesn't slow down. SUVs are heavy, so braking systems have to be smart. Anti-lock brakes prevent wheel lockup during hard braking, while electronic brake force distribution balances pressure between wheels. But the real game changer is electronic stability control, or ESC. It uses sensors to detect if the SUV is skidding or beginning to roll, and it automatically brakes individual wheels or reduces power to bring it back in line. Studies show that ESC has cut rollover-related fatalities by more than 50%, one of the biggest safety wins in modern automotive history. Tires might seem basic, but they're a silent hero. Every bit of grip, braking, and cornering comes from 4 small patches of rubber touching the ground. Engineers design SUV tires to handle more weight, maintain grip on multiple surfaces, and stay tough in all weather. Reinforced sidewalls prevent damage off-road, and modern tire pressure monitoring systems make sure inflation stays perfect, because even a slightly deflated tire can reduce grip and increase rollover risk. Now let's talk about the invisible safety layer: crash energy management. When a crash happens, the goal isn't to resist the force, but to manage it. SUVs are designed with crumple zones, areas at the front and rear that collapse in a controlled way, absorbing energy before it reaches passengers. The passenger cell, or safety cage, stays strong with high-strength steel pillars and crossbeams. Inside, airbags work with split-second timing: front, side, curtain, and even knee airbags, each one designed to protect different parts of the body. And in the event of a rollover, curtain airbags deploy and stay inflated longer to protect your head from side impacts and broken glass. Of course, SUVs are taller, so roof strength matters. Modern SUVs must pass strict roof crush tests, meaning the roof can withstand several times the vehicle's own weight. Advanced rollover sensors can even detect when a tip is starting and apply the brakes or adjust suspension stiffness to help recover before it happens. It's a blend of structural strength and predictive technology working together. Under the skin, materials are carefully chosen to make the SUV both strong and light. High-strength steel provides rigidity where needed, while aluminum and composite materials cut weight in non-crash areas. Adhesive bonding and laser welding make the structure even stronger without extra bulk. This smart mix of materials gives you a safer SUV that still handles well and saves fuel. Now here's where modern engineering really shines: software. Today's SUVs are like rolling supercomputers. Dozens of sensors measure wheel speed, yaw rate, acceleration, and steering angle, while cameras and radar watch the road ahead. These sensors feed into control systems that make thousands of adjustments per second. The result? A vehicle that can react faster than any human. If you take a corner too quickly, it corrects. If a car stops suddenly ahead, it brakes for you. It can even adjust its suspension or torque balance before a sharp turn. That's the real magic of modern SUV technology. Invisible precision working silently under your feet. Electric SUVs take this science to the next level. The massive battery pack sits low in the chassis, which lowers the center of gravity and makes them incredibly stable for their size. Instant torque from electric motors gives perfect traction control, and regenerative braking adds another layer of stability. But electric SUVs also have unique challenges: heavier overall weight and the need for strong crash protection around the battery. Engineers tackle this with reinforced battery enclosures and sophisticated cooling systems that prevent overheating during accidents or high-load driving. And none of these designs hit the road without brutal testing. Organizations like NHTSA and IHS in the US perform thousands of crash tests: front, side, pole, and rollover. Engineers use computer simulations to model how metal bends, how airbags deploy, and how the human body moves during a crash. Each test result feeds back into design improvements. That's why today's SUVs have never been stronger or safer in real-world crashes. Still, safety doesn't stop with engineering. It includes the driver too. Overloading your roof rack, carrying too much cargo, or ignoring tire pressure warnings can all compromise stability. Engineers build guardrails against misuse, but no system can replace smart driving. So, it's important to know your SUV's limits and respect them. Real-world examples show just how far SUV engineering has evolved. High-end models from brands like Mercedes, BMW, and Range Rover use fully active chassis systems that combine adaptive air suspension, rear-wheel steering, and electronic roll control.